Today we're going to talk about doing dilations on a square grid. So we've talked about them on a circular grid and on a paper with no grid and how to kind of figure out what is happening. So we're going to start with how to estimate a scale factor. And this is if you're not using some type of measuring device. Now I'm using one to kind of show you, but we're going to do it without and then kind of show you if we're close or not. So this first one here we have an A, B, and a C. And it says we're going to take and estimate the scale factor. So point C is the dilation of point B. So that means we moved B to C. Okay, so C is a dilation from B. And the center of dilation is A. So here is our center. And we moved it, and it's done by some kind of scale factor. So we're going to estimate that scale factor, and you should be able to explain what's going on. So if we start here and we think we're moving B, how far is A to B? So if we look from A to B, we can kind of think, okay, well, that's paper phone, kind of eyeball it. And if I just kind of roughly guess, I would think that's about the same as to about right there. That's probably pretty close. I know that it would be at least 2 away, but then I have this little piece. So that little piece is not a whole lot. Maybe it's 1/4 of an inch. Maybe it's just a few millimeters. So we could use our measuring device, and I'm going to use this little ruler here. And if I line up and I say, oh, okay, well, from A to B is about, I don't know, 3.4. So if I do 2, there's my 3.4, but then I still have that little chunk left. I got pretty good about guessing there. So I have about 1/4 or 0.5 millimeters left. If I did it with inches, I could say it's about 1 1/4. So then 1 1/4 would be about here. And I'm going all the way to C, which is going to 3/4. So if I wanted to check to see how much that is, I'm about not quite a half, I would say 1, 2, 3, 4, 7, 8, 7 8. No, not 7 8, 7/16. Roughly around there. So we know it's more than 2. I would say maybe it's 2.4. Roughly around there. I'm just estimating. So I know it's not a whole number because I had a little piece left. So when we're estimating, we're kind of getting close. It kind of helps us to see what exactly is there. All right, so let's go down to question 4.2, dilations on a grid. So we're going to find the dilations of quadrilateral A, B, C, D, what's drawn here, and our center is P, and our scale factor is 2. So let's use a color here. We know we're doing a scale factor of 2, so anytime a scale factor is bigger than 1, we know the shape is going to be getting bigger. So we know the shape that we're going to make is going to be bigger than what we started with. So we're going to start and we're going to look at our center point of P, and we've got to look at every single point. It's not dead in the center, it's not a circle, so we've got to look at every single point. So if we first start with A, we go up 1, 2, and over 1. That's doing one move. Well, we have a scale factor of 2, so we've got to do that again. We've done it once, now we're going to do it again. So from P, it's up 2 and over 1, so we're going to go up 2 and over 1 again, and this is going to be our A prime. Now let's go over to B. So B is up 1, 2, and over 1, 2, 3, 4, 5. So we're going to do the same thing again. We're going to go up 2, 1, 2, and over 1, 2, 3, 4, and 5. This will be our B prime. Now if we look at C, C is going down 2 and over 1, 2, 3, 4, 5. So we're going to do that again because this is a scale factor of 2. So 1, 2, 1, 2, 3, 4, 5. And there will be our C prime. Make sure you put those prime numbers. Now let's look at D. We went down 2 and over 1. Let's do that again. 1, 2, and over 1. This is going to be our D prime. Now let's connect these together. So we have here and line here. So now, oh, that's a pretty crooked line there. So we have something that is 2 times bigger. I'll erase some of these little marks so I can see my line there. Alright, so we have something that's 2 times bigger. Now, this asks you just to dilate it, but let's say if the problem continued and it wanted to know about maybe the area. So remember how we find area with a rectangle. We got to know the length and the width. So let's start with our basic one. We had 1, 2, 3, 4. So this is 4. And we had 1, 2, 3, 4, 5, 6. This is 6. And remember, area is length times width. So we have 4 times 6, and we get 24. And we don't know what the units are in, so we'll just say units, and area is always squared. So now let's see how much bigger the new figure is, the one that we did a scale factor of 2. A lot of times people think, well, it's 2 times bigger, so the area is going to be 2 times the size. But let's look. So this is 1, 2, 3, 4, 5, 6, 7, 8. Well, that makes sense. 4 times 2 gets us 8. We'll use a scale factor of 2. So if we do 6 times 2, from A to B segment should be 12. So let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it is. But now let's do our multiplication. Length times width, so 12 times 8. Well, 8 times 10 is 80, and 8 times 2 is 16. And add those together, and we have 96. So this is 96 units squared. So it's not double the area. It's actually more. So if we think about how much more, if we do 96, and we take away 24, let's see, we have 2 and 7, 72. Ooh, it's a lot bigger, quite a bit bigger. It's actually, if we think of what can we multiply 24 to 96, we can see that the area is 4 times bigger. So when you're thinking about area doesn't change by the same scale factor because you've got multiple dimensions. So if you're asked that question, make sure you know. All right, let's move on down. We're going to find the dilation of triangle QRS with center T using a scale factor of 2. That's for number 2. So here's QRS. Let me use a highlighter here. So we have QRS triangle, and we are going to use the center as T, and we're going to do a scale factor of 2. So if you think about where your center is, if you're using a scale factor that's larger than 1, your shape is getting bigger. So you know that your new image is going to be further away from the center of dilation than what you're moving. So we have to think about how far do we get. Now if we look, we have a grid, so let's look at point Q. From center, we went up 1 and over 1, 2, 3. So we're going to do the same thing with the scale factor of 2. Up 1 and over 1, 2, 3. And we're going to put our point there, and that's going to be Q prime. Now, we're going to move our R. We can do R or S next, doesn't matter. So let me erase these little marks so we can see. So we're going to do over to get to R. We go over 1, 2, 3, 4, and down 1. So we're going to do the same thing. Over 1, 2, 3, 4, and down 1. This will be our R prime. All right, now let's do S. We went down 1, 2, and over 1, 2. So we're going to go down 1, 2, and over 1, 2. And we have our S prime. Now we can take our ruler, our straight edge, or our tools, and we can mark our line. If you're using Cami, you can use this the shape tool, the line segment, and it'll make you a straight line. And now we have a dilated figure of a scale factor of 2 from the center T of our original. Now number 3 says we're going to find the dilation of QRS with the center T, but this time we're going to do scale factor of 1/2. So if our scale factor is less than 1, we should know that it's going to be getting closer to our center. So if we think about what we did originally, we went up on Q. Let's use a blue color here. To get to Q, we went up 1 and over 1, 2, 3. So this time, instead of going up 1, we're going to go up half of that. So we go up half of that, and instead of going over 3, we're going to go half of that, which would be 1.5. So here's 1, and then a half is about there, and we'll call that Q double prime. Put my little marks back. So Q double prime. That's a different move. All right, let's do the same thing with R. So originally we went 1, 2, 3, 4 over and down 1. We're going to do half of that. So we're only going to go 2 over, 1, 2, and instead of 1, we go half of that. So then our R prime is here. Now we're going to do S. So we went normally 1, 2, 1, 2. We're going to do half of that. So we're going to do 1, 1. And our S double prime is there. Then connect them together. So this is a perspective kind of drawing, something you use a lot this in art. So it's a really cool way to be able to keep everything scaled. Those little dotted lines, you could draw them and take them away. So we've made the blue one in a scaled copy that's half, and it's still proportional with the center T for both of them, and then the red one is 2 times bigger than our original. All right, let's look at this really cool triangle drawing. So all these triangles are dilations of triangle D. So let's look at triangle D. We're going to highlight it so we know which one we're talking about. So all of these triangles have been dilated from D, but different scale factors were used. So to get C from D was a different scale factor. To get G from D was a different scale factor. So what do triangles A, B, and C have in common? Well, if we look at A, B, and C, we notice that, and they told us our center was P, that they're much smaller than D. So they got closer. So if they're smaller, they probably had a scale factor that was less than 1. So some type of fraction that's less than 1. So maybe, I don't know, a third, or a half, or a fourth, or an eighth. Could be anything, but it's less than 1. What do triangles E, F, and G have in common? Well, here's E, F, and G. Okay, well, we're comparing it to D, to triangle D right here. So let's see. They're bigger. They're still using the same center point. And if we look and say, okay, they're much bigger. And then what does that tell us about the different scale factors? Well, if we got bigger, our scale factor would have to be larger than 1. So it could be a whole number, or it could be like 2.5 or 2.8, or like when we estimated at the beginning, we said 2.4. So it could be something that is even bigger. Now, you could find out close by measuring from here to this point kind of what you do, like we did in our ones without a grid, because this doesn't have a grid. And you can think, okay, well, here's a certain amount, and then how far is it from here to here? It corresponds, and see what did you do to get there. They're not asking you to do that. They just want you to realize and see the correlation and the connection of the smaller ones versus the larger ones.